Waterfall. Waterfall, waterfall. All eyes are tracking the board at this time. All eyes are tracking the board. All eyes. Still waiting on some few people. Thank you, Summer, for tracking. Thank you, Janai, for tracking. Thank you, Jeremiah, Jalen, Colin, Aaron, Anaya, Landon, Aaron. All right, so let's talk about what we're doing today. So today we're doing lesson 10. Lesson 10 is choosing a solution method, okay? For our objective for today, students will be able to analyze graphs and systems of equations to determine the number of solutions, all right? Our key question today is, what is a given system of equations, and how do we determine which method to use to find the solution? All right, so let's look at our do now for today. Our do now was to determine the number of solutions to each system of linear equation by inspection. All right, so look at number one. Just looking at number one. Raise hands. Who has an idea of what number one may be, Asaya?
One solution.
One solution. Why do you say a one solution, Asaya?
You have to say one intercept.
So they have the same y-intercept. What is different though, Asaya?
The slope.
The slopes, right? So that means this has a what would line would this make on a graph?
Our intercept is no, our intercept.
An intersecting line, right? Because we know that it's one solution, right? It has the same y values. So we know that the line is intersecting at the same point on the y-axis. On the y-axis, right? So this would be a one solution, okay? Number two.
One solution. One solution.
Raise hands. I'm on the call on raise hands. Thomas, what you say for number two?
One solution.
Why do you say it's a one solution, Thomas?
Because the slopes are different and y-intercepts are different.
Yes. So my slopes are different. Also, my y-intercepts are different. So I agree with Thomas. This would be a one solution. Thank you, Thomas. Number three, raise hands. Cadence, what you say for number three?
Indefinite solution.
You said what?
Indefinitely many solutions.
Okay, so infinite solutions. So, why do you say it's infinite solutions, Cadence?
Because the slope is the same and the y-intercept is the same.
Yes, so my slopes are the same and my y-intercepts are the same. So I agree with Cadence. This would be a infinite solution. Anybody have any questions about why number three is an infinite solution? And number four, Aaron. Why is it a no solution, Aaron? You want to call on a friend, Aaron?
Sure.
Why would this be a no solution, Marla?
What?
Sure.
Because the slope is the same.
The slopes are the same, but what is different, Marla? So my slopes are the same, but my y-intercepts are different. So this would be a no solution. Is there a number that you guys want me to go over?
Three.
No.
Three?
No.
Three?
No.
Three. And finish.
Raise, just show me on your hands what number you want me to go over.
None of
Show me on your
them.
hands. All right, so I see threes, okay? So looking at number three really quick, all right? So if we look at number three, we have x plus 2y equals 8. Can somebody tell me what form the first equation is in?
Slope equals y.
Slope intercept or y-intercept form, correct? What about the second equation? What form is that?
Standard.
Standard form. What must we change standard form problems to?
Slope intercept.
Slope intercept. So let's go ahead and do that now. What needs to move first?
The X.
X. So how would I move the X? What operation would I do to move the X? The inverse operation, right? So what am I doing with X? Adding X to both sides, okay? Alright, so my new equation, what happens with the two X's on this side? They do what? They cancel out, correct? So what's left on this side of my equation? 2y. 2y equals what? Right. So from this step, am I finished? No. What do I have to do in order to get y by itself? Divide everything by 2. So my new answer, my new equation should be what? Help me out.
Y equals 1/2 x plus 4.
Y equals 1/2 x plus 4, okay?
X is important.
We notice that they have the same slope, and they also have the same what? Y-intercept, okay? So this will be an infinite solution. All right, so once you have that, go ahead and turn to the next page for me. Go ahead and turn to the next page.
I already did it.
Thank you, Molly, for getting there. Thank you, Janai, for getting to the next page. Thank you, Kai, for getting to the next page. Kylie for getting to the next page. All right, so let's look at what it says for problems 1 through 5. So for problems 1 through 5, it wants us to indicate the method we use to solve each system of equation, okay? So let's look at number 1 together, all right? Let's look at number 1. So number 1, can somebody tell me what operation would I have to do for number 1 in order for me to break down the first problem?
The elimination method.
Distributive property, right? So I'm doing distributive property. What would my new equation be for number 1?
Negative 1/2 x plus
4.
Negative 1/2 x.
So y equals negative 1/2 x plus 4. Does everybody agree with that?
Yeah.
Everybody agrees, right? So we did distributive property, correct? Alright, so just looking at this equation, what type of solution would I get for this equation? Infinite solution. So we're gonna all write infinite solution in this first box, alright?
I thought you were supposed to put the type of method.
What method would be best in order to solve this problem?
Elimination method.
So my 3 methods are on the board. I have graphing, substitution, or elimination.
Elimination. Elimination.
Substitution.
Elimination.
Raise hands, raise hands. So, who says graphing? Raise hands. Who says graphing? I got 2 for graphing. Who says substitution? Okay, I got 3 for substitution. What about elimination?
Got 2 for me.
About 5. Who just doesn't know? Okay, cool. All right, so just looking at this equation, right? I think the best method in order for us to solve this equation would be graphing. Why would it be graphing, Colin?
Because they show us the same way.
So it will show us the same line, correct? So it has the same slope and the same y-intercept, right? So it's already given us everything that we need. It's giving us our slope, and it's also giving us our what? Y-intercept, right? So our method would best be graphing, okay? All right, let's look at number 2. Let's look at number 2. So looking at number 2, which method would be best for me to solve number 2? Substitution. Why do we say substitution, Journey? Journey?
Because it already gives you the y value.
So does it give me the y value?
No, the y.
Or does it give me the x value, Journey?
It gives you the part.
It gives me the x value, correct? So if it gives me the x value, the best method would be what? Substitution. All right. So go ahead and write substitution in for the method that we're using. All right. So just looking at number 2, does anybody have an idea of what type of solution that will make them? Just taking a guess. Just looking at the line. What type of solution? One solution, no solution, or infinite solution? Why do we think one solution?
Yeah, one solution. It's gonna be one solution.
It would be one solution. Why, Colin?
It has
Me?
different slopes.
He said Kylie, not Colin. Because they have different slopes and different y-intercepts.
Yes, I agree. So they have different slopes and they also have different y-intercepts, all right? So this one would be a one solution. So go ahead and write one solution on your paper. We're writing one solution, okay?